what I'm going to be doing today is making some comparisons between Agile and evolution. They actually have quite a bit in common. And we can use the facts that we know about evolution to help us in our endeavors in an Agile environment. So, first of all, I'm going to start with one of the common myths about evolution. One of the main misunderstandings of evolution is that you start with something simple, say a single-celled organism, bacteria or something, and then you go in a straight line, and then that ends up with something complex like human beings. And then somewhere along the way, maybe around here, you find monkeys. I can't draw a monkey, so I'm just going to write it. And maybe along a different straight line path, you'll find plants. Maybe fish would be here. And this is actually one of the most common misunderstandings of evolution. And it's far too commonplace. I'll give you a moment to see if you can figure out what exactly is wrong with this and why it wouldn't work. So, if instead of biological evolution, let's take a look at the chances that starting at Mount Rushmore, that's my mountain there, coming down, trying to go in a straight line path to, say, the Alamo. The building, that's the Alamo. So, it's about 1,000 miles away. And the Alamo is about 100 feet across. So it turns out, if you start here and randomly go in some direction, any random direction, there's about one chance in 1 million that you'll get from Mount Rushmore to the Alamo. That seems reasonable. You could gather up a million of your closest friends, go over to Mount Rushmore, blindfold them all, they spread out. One of them will probably run into the Alamo. But let's look at something a little more complicated, something a little farther apart. So here we have the Earth, and over here we have Alpha Centauri. It's the closest star to Earth. Now, it's about 4 light years away. And the star is about 10 to the 8th meters across. So that gives us about, if we start out at the Earth and go out randomly, choose a random direction, we'll have about 1 chance in 3 billion that our spaceship will randomly arrive at Alpha Centauri. So, if you gather up just about every person on Earth, make them all their individual spaceships, and then send them out randomly, one of them will probably get near Alpha Centauri. There's a good chance one of them will reach Alpha Centauri. That still seems a little bit reasonable. 1 chance in 3 billion. Well, if we look at the chances a human could have evolved randomly without any kind of natural selection, it's not even really worth defining what it is, because it's 1 chance in something larger than the number of molecules in the universe. So it just could not have happened, given the amount of time, 13 billion years since the Big Bang. Not even partly. So, that's why the straight line approach is absolutely wrong, and we need a different model. programmers are really fond of algorithms. What we're going to do is we're going to use a genetic or a evolutionary algorithm for our spaceships to start at Earth and end up at Alpha Centauri. As we're going to see, it's going to take many fewer spaceships than 3 billion. So we're going to define some things, first of all. In evolution, and we're going to have our space equivalent over here. Spaceships. Evolution, we have mutations. And we're going to represent those with random hyperspace jumps, where you jump a little bit out into space, but you have no idea which way it's going to take you. Remember, they're going to be small jumps. Small. Hyper jump. And in evolution we have natural selection, the survival of the fittest, the best things get to continue on. So we got natural selection. And over here we're going to represent it with a central computer. So the central computer is going to decide which spaceships are doing the best and let those spaceships continue on and not give any more resources to the ones that are doing poorly. Now in evolution you have an environment which has things to eat and resources you need. In our model, we're going to say the central computer gives out an energy source. Now we don't have any technology that can beam energy yet, I don't think, but perhaps in the future we will. And in evolution, our basic unit is the organism. Well, basic unit is the gene, but we'll pretend it's the organism for now. And we're going to use spaceships.